everyone, welcome back to my channel. Now we are doing chapter 1 force uniform circular motion. We will understand this concept in this video. This full unit we will understand. So let's start. What is uniform circular motion? What is it? When a particle moves with a constant speed in a circular path, its motion is said to be a uniform circular motion. In this, there are some keywords that I would like to tell. Particle moves with constant speed in circular path, motion is said uniform circular motion. These 1, 2, 3, 4, 5, 6. 6 are the keywords of this definition. These 6 words should be there in your definition, then only you will get full marks of definition what is uniform circular motion. So, when a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. When a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. Just repeat this definition 2 to 3 times and learn it. Now, this is the definition. We have done that. Now, let's see further. In such a motion, a particle travels equal distances along the circular path in equal intervals of time. So, the speed of particle is uniform, but the direction of motion of the particle changes at each point of the circular path. The continuous change in the direction of motion implies that the velocity of the particle is non-uniform, that is variable, and the motion is accelerated, means it is acceleration. It is an acceleration. The direction of velocity at any instant in a circular path. Now figure 1.43, let's show. This is the figure 1.43. It is in your book, just open the book. Shows a particle moving in a circular path in a horizontal plane with uniform speed v in an anti-clockwise, means like this direction. The particle travels each quarter of circle AB, BC, CD and DA in the same interval of time t is equals to t upon 4, where t is the time taken by the particle to complete one round of the circular path. Thus, the speed of the particle is constant, that means uniform, but the direction of motion of the particle is different at different points of the circular path. At any point, the direction of motion is along the tangent drawn at any point of the circular path. This is the circular path and tangents are from the circle, like V, this one, V, this one, V. All these are tangents, okay, going through the circle. At the point A, the direction of motion of the particle is towards north, right? It is towards north at the point A. You can see it here. After completing quarter of circle at the point B, the direction of motion of particle is towards west. After completing half circle at the point C, this all they are telling. This is west, this is south, this is east. Like this they are telling. Direction of motion of the particle is towards south, and after completing 3/4 of circle, when the particle is at point D, this is the point D, right? Its direction of motion is towards east. Yes, it is towards east. This is east. Thus, the velocity of the particle in circular motion is variable, or the circular motion is an accelerated motion even though the speed of the particle is uniform. Now, this is very important. Difference between uniform circular motion and uniform linear motion. This can be asked as 3-mark question in a board paper or first assessment whenever you have this chapter. First assessment mostly and board. So, this question can be asked for 3 marks. First is uniform linear motion and second is uniform circular motion. Now let's see. Uniform linear motion, this speed is constant, and in uniform circular motion, speed is uniform. In uniform linear motion, velocity is constant, and uniform circular motion, velocity is variable. Uniform linear motion is an unaccelerated motion, and uniform circular motion is an accelerated motion. It always goes in acceleration. It is always circular, okay? Now these 3 points you must learn. You can take the screenshot or write it down in your notebook. Centripetal force is also known as real force. Centripetal force is also known as real force. Now what is centripetal force? Centripetal force is the force acting on a body moving in a circular path in a direction towards the center of the circular path. इसका मतलब है सेंट्रीपिटल फोर्स वो फोर्स होता है जो एक बॉडी पे एक्ट करता है, जो बॉडी सर्कुलर मोशन में या सर्कुलर पाथ में घूम रही है और वो बॉडी अंदर की तरफ घूम रही है, टुवर्ड्स द सेंटर, मतलब सेंटर की तरफ फोर्स आ रहा है. ओके, इट इज नोन एज सेंट्रीपेटल फोर्स. दिस फोर्स इज ऑलवेज डायरेक्टेड टुवर्ड्स द सेंटर ऑफ द सर्कल. ये फोर्स जो है, समझो ये सर्कल है तो इसके हमेशा अंदर ही ये फोर्स एक्ट करेगा, ऑल डायरेक्शन से ये अंदर ही फोर्स एक्ट करेगा. सो दिस इज नोन एज सेंट्रीपेटल फोर्स, दैट इज रियल फोर्स. The direction of force and also of acceleration changes at each point of circular path. Of course, direction जो है force की और जो acceleration है वो हर एक circular path, मतलब ये circular path है तो हर एक point पे वो change होगा, यहाँ पे change होगा, यहाँ पे हर एक point पे वो change होगा. Magnitude remains the same. जो magnitude होता है वो हमेशा same रहता है और जो acceleration जो होता है वो variable होता है या non uniform आप कह सकते हैं. Now this example देखते हैं. In an atom, an electron moves around the nucleus in a circular path for which the required centripetal force is obtained from the electrostatic force of attraction on the negatively charged electron by the positively charged nucleus. Nucleus is of positive charge, electron is of negative charge. These both force of attraction we have learned, right? Positive and negative attract each other. So like this, in an atom, electron moves around the nucleus in a circular path. So this is an example of centripetal force. It can be asked, in an atom, an electron moves around the nucleus. Which type of example it is? You must write centripetal force. Now, a planet moves around the sun in an elliptical path for which the gravitational force of attraction on the planet by the sun provides the necessary centripetal force. Thus, you can see planets are revolving around the sun and they are towards the gravitational force of attraction. Due to that, planets are always revolving around the sun and provides centripetal force. You can see it here. So it can be asked this also. All the examples, any example they can ask which type of example it is. You should remember these four examples of a centripetal and other are of centrifugal. Now Moon moves around Earth in an elliptical path for which the gravitational force of attraction on Moon by Earth provides the required centripetal force. This is same as planet moves around the Sun. When a stone tied at the end of a string is whirled in a circular path holding its other end in hand, the tension in the string provides the centripetal force. In the absence of this force, the stone will not turn to move in a circular path. You can see the woman or girl is she has done a stone, she has tied at the end of a string and it is creating a tension, and the tension in the string is providing the centripetal force, that is the force, center seeking force. In all the above examples, the body moves in a circular path with a uniform speed. You must have noticed under the influence of centripetal force, and it is in state of dynamic equilibrium. Yes, it is in motion, so it is in dynamic equilibrium. Static means rest, dynamic means it is in motion. The centrifugal force is in fictitious force, means not a real force. A force formed by an observer moving with a body to be acting on a body in a direction away from the center of circular path is called centrifugal force. Now I will see. This is see here. The force will be acting towards the end of this circle. This is called as centrifugal force. Centripetal force is acting inside the circle. Force is coming inside and it is like going outside. You must have seen, right? So this is called as centrifugal force. This definition you must learn. Centrifugal force is in direction opposite to direction of centripetal. Yes, centripetal is in between and centrifugal force direction is opposite to centripetal. Centrifugal. Centrifugal force is a direction opposite to the direction of centripetal force. Magnitude is same as centripetal force and it is not a real force. I have told you it is a fictitious force. So it is not a real force. You must remember which is real force and which is not. Centripetal is a real force and centrifugal is a fictitious force. That is not a real force. Now let's see one example. There are two examples. I'm explaining only one. If you have any doubt in second example, you can comment me down. I will make a video on that also if you have any doubt. Okay. Now figure 1.45 shows a ball tied at one end of the string, the other end of which is tied at the center of a merry-go-round. Initially, when the platform of merry-go-round is stationary, the ball is seen stationary and the string is loose. As the platform starts rotating, the ball rolls towards the edge of the merry-go-round and the string becomes tight due to tension T developed in it. Let us consider that the motion of the ball is observed by two persons. First, standing outside the merry-go-round on the ground at M1 and standing on the platform of the merry-go-round at A, okay, this one and M. So these two persons are observing the motion of the ball. The person standing on the ground at M outside the merry-go-round observes that the ball is moving in a circular path that is shown by dotted line. You must have seen this. See, this is the dotted line. See in your book, you will clearly see there is one dotted line after the black line. Okay. While the person standing on the merry-go-round at A observes that the ball is stationary placed just in front of him. So this person observes that the ball isn't stationary. It is not moving. Means it is static situation. As the merry-go-round rotates, the position of the person of the platform changes from A to A dash, A dash dash, A dash dash dash, and dot 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 infinity. And the ball reaches at the position P dash, P dash dash, P dash dash dash, and infinity, respectively, as it remains at rest always just in front of him. The different observations of the same motion by the two persons at M and A are explained as follows. So one person is seeing that the ball is in motion and other is seeing that the ball is in rest, means it is stationary. Now, what conclusion we have seen from these two examples? I have explained one. Second is same like that. So means only one example is there, but explanation is there. So you must read that explanation thoroughly. Okay, it can be asked. So that's why. Centrifugal force is not a real force. It is a fictitious force. The only real force involved here is the force of tension in the string acting towards the center. A force which really does not exist but is considered to describe or understand a certain motion is called fictitious force or a virtual force. Fictitious is also known as virtual or not real. So we have concluded that the centrifugal force is not a real force. It is a fictitious or virtual force. And the only real force is the centripetal force that is acting towards the center by tension in the string. Okay. Thank you all to see this video and come to the end of this video. Subscribe to my channel. Press the bell icon. That is very important. You must press the bell icon after subscribing. If you just subscribe, you will not get the notification of my new videos. So after subscribing, press the bell icon so that you will get the notification whenever I upload my new video. Just press the like button also if you liked and understood the concept uniform circular motion and centripetal and centrifugal force. In next video we will be doing exercise 1C of Selena book. Till then, bye bye.